Hey everyone, in this video we're going to look at ray diagrams for diverging lenses. We just finished up with the converging lenses. So the rays for diverging lenses, they're going to follow very similar rules. Let's take a look at ray number 1 here. It's going to come parallel to the axis, but it's going to diverge. Since it's a diverging lens, the rays are going to come apart along a line emerging from the near focal point. Right, so even though this lens here, it does have a focal point on each side, the rays cannot just go through the focal point on the other side because that would be a converging lens. So the rays diverge as though they came from the focal point on that near side on the left side. The second ray goes through the center and keeps going, so that's the easiest one. And then the third ray is a little bit harder here. So it's going to go toward the focal point on the other side, on the far side, but as soon as your ray hits your lens, it has to bend. The lens refracts that light, so it's going to bend parallel to the axis. So the way that I remember these rays, I do my similar little symbols here, but it's different from the converging lens, right? So the converging lens, what we did for those is we said parallel on the left side, focal point on the other, it went through the center, focal point on the left, and parallel on the other. That was the converging lenses. For the diverging lenses, what you notice is that it's parallel on the left side here, but it's appearing to come from the focal point on that same side. So it's parallel focal both on the left side and then center, and then it's going to be focal parallel, but they're both going to be on the other side. So it takes a little bit getting used to, but that's how I remember it. So this is for the diverging lenses. Let's take a look at a ray diagram in action here. The good thing is that they're all going to look the same no matter where the object is placed when you have a diverging lens. So let's look at ray number 1. It's parallel to the axis and then it diverges as though it came from the focal point on that same side. Notice where it's bending whenever it hits that straight line. Ray number 2 is going straight through the center, keeps going. And then ray number 3 is trying to get to the focal point on the other side, but as soon as it hits that lens, it's going to emerge parallel. What are the properties of the image that is formed right here? So the 3 rays diverged, so you had to trace them back and see where those rays intersected here to form the image right here. What are the properties? Well, whenever you have to trace rays back to form the image, that's a virtual image because the rays did not actually intersect. We can see that the image is smaller than the object and it's also upright. So those are the properties of your image that is formed. So what is a good application of this is putting corrective lenses, right, contact lenses, so that you can see better, so that things aren't blurry. So what this picture is showing here is the ray here on the bottom. The straight ray is what the light would look like if you didn't have a lens in front of your eye. So those incoming rays, they get bent here by the lens and the fluid here, they get bent, and you can see this particular eye, it bends the rays and they intersect at this point. But you're only going to see a sharp image when the image is formed on the retina, which is on the back surface here. If the image is formed here where the rays are intersecting, it's going to be blurry. So what this picture is showing is that if you put a diverging lens here, then these rays are going to diverge. Instead of coming straight here, they're going to diverge. And now when your eye does its work to bend the light rays, since the rays are initially further apart thanks to the lens, then now when they converge, they actually converge here on the retina. A diverging lens is actually used to fix nearsighted when you cannot see distant objects. You see that these distant objects have these parallel rays that did not converge on the retina. You can actually use a converging lens to fix farsightedness. So that's a pretty cool application. Let's just look at a summary of all the different ray tracing diagrams that we've seen. This is for the mirrors here. A converging mirror always formed, well, not always, it formed a real image when the object was further than the focal length, but your converging mirror formed a virtual image when your object was in between the mirror and that focal point. You can see that we had to trace the rays back. And a diverging mirror always formed a virtual image. And then for the lenses, it's very similar. Your converging lens can form a real or virtual image depending on the placement of the object. When the object is further than the focal point, then you'll have a real image, but when the object is closer, you'll have a virtual image. And the diverging lens always forms a virtual image. That's it for the video. The next thing we're going to look at is equations so that we can get more exact answers.